All right, welcome everyone. My name is Heske van Doorne. I'm with the Young Scholars Initiative at INET. I'm really excited that you're here for another episode of something we've called Early Career Time. Early Career Time is a series, an ongoing series, in which we discuss and we explore the challenges that we face as early career researchers. So that ranges from things like publishing and the job market, to writing and teaching, but also mental health and work-life balance. And we're very excited that you're here today for a session that looks to be very interesting. It's called I'm an Economist, How Much Coding Should I Know? And this session was designed and organized by Kurt Sem, who is a junior economist at INET, but also a PhD student at the New School. And Kurt has brought together three amazing panelists to really unpack this question to you from different perspectives. So I think you'll really enjoy the conversation. As you can tell, you're in the Zoom with us, so please just stay on mute until we switch to a Q&A format, and Kurt will signal to you if you can unmute yourself and ask questions directly. But in the meantime, you can also use the chat. I'm in there with you, so feel free to note down, maybe where you're calling from and what brings you excited to be here with us. So without further ado, let me turn it over to Kurt. Kurt, thanks so much.
Thank you so much, Heske, for that lovely introduction. Good morning or good evening, no matter where you are joining us from around the world. Thank you so much for coming. And I hope that by the end of our session today, we can get a clear answer or close to a clear answer of how much, if you want to do economic research, how much coding do you have to know? My ambition for this is 5 years ago, I was an English literature major, and now I'm very comfortable with Stata and Python and R. And I was like, when did I learn these things? I have no idea. And so my question was, I wanted to see how other people and how other economic researchers dealt with coding in their own work. And luckily, we have three really great panelists that are going to discuss with us today of their own journey with coding, why they started coding. And towards the end, the last 20 minutes, we'll open it up for questions. But also feel free to put your questions in the chat as they arise, and I'll make sure that we're keeping on time. So let me start by introducing our wonderful panel guests. First, let me introduce Pier-André Bouchard St-Amant, who is where do I start with all your accomplishments? So the main thing is he's at the National School of Public Administration. He teaches quantitative methods to economic graduate students, and most of his work is deals with the analysis and optimization of public policy for business practices. Then we have Thomas Herndon, who, as I just learned this morning, just got tenure at John Jay College at CUNY. So good, we're proud of him and congratulate him for that. And he is one of his more famous pieces of work is the growth in a time of debt, where he actually pinpoints a coding error, and I'm sure he'll speak about that more for a European study on austerity policies. And then finally, we have our data scientist in the group, Tim Fong, who we really appreciate for him joining us today. So we can kind of find that line of, well, I want to do economics, but there's so many coding languages, which one should I pick or stick to? And he has a master's in statistics from Baruch College and a JD from the University of San Francisco School of Law. And he's currently working on post-Keynesian price theory. So we have a really great group, and I think we can just go ahead and get started with letting the panelists introduce them. And I would just ask for we'll start with you, Pier-André, if you could touch on 3 questions. Why did you learn how to code? What language did you learn and why? And then how did you learn how to code? Did you take a course at school in your undergrad or grad? Did you learn yourself? And what was just kind of why'd you start coding?
Very good. Thank you. Thanks, Kurt, for the presentation. Hi to Tim and Thomas. Hello, everyone. and thanks for the invitation. I come from a background which I guess, like most of us, is not a direct curriculum in economics. I started actually with a bachelor's degree in pure mathematics, and then I took a turn for public policy, and in a general sense, how the government intervenes in various sectors of an economy. And so I got interested in programming because we had that nasty little class called numerical methods that was part of the curriculum at the time, which had to deal with how errors accumulates when you do numerical calculations. And that's how I kind of got started into programming. I started programming with some very unusual languages, such as Maple, if some of you know about this, and mostly C, which is a very low-level, hardcore programming language, not very forgiving, I would say. So that, I've learned programming the hard way, maybe one would say. And the focus was very much on algorithms, much less on, economic questions and policies and so on and so forth. So I started economics with actually a very good background in programming. Like I had some good knowledge on how to program things, but much less on how to answer social questions or answer economic questions in a broader sense, and use programming languages to do so. So I would argue, and perhaps that's the introduction for another question, but I would argue that it's useful for economists or people interested in policies or how society behaves in a wide sense, that programming is useful for maybe at least in one of those three situations. So the first one is any kind of model where there's a fixed point logic. Where something depends on something else, and that something else depends on the first thing as well, where there's some sort of a interaction between agents, so to speak. Any point where there's heterogeneity, when there's a wide variety of people and a wide variety of different parameters and so on and so forth, and this is heterogeneity that generates something interesting, something new that isn't there when there is none. So in fiscal policy, for instance, if you're looking at inequalities, that's kind of a given. You need to dive into this like pretty heavily. And the other point, maybe when there's multiple agents. So it's not exactly the same thing, but when there's a lot of different, firms or people interacting in non-trivial ways, that would be very interesting actually to have a programming language to simulate and see how those interactions yield some social outcome that would not be observable otherwise. With that being said, I'm sure some other people on the panel have some interesting answers and backgrounds as well. So I'll leave it there.
Thank you so much, Thomas.
Hey, how's it going, everybody? Nice to meet you. My name is Thomas Herndon. I'm an associate professor over at the John Jay School in CUNY. And I teach research methods to the master's students we have. And I've also taught like stats at whatever level. So a lot of my interest in coding is just empirical methods. And, there's been a real empirical turn in economics. So we have just a cornucopia of data now, and like really fine-grained detailed data. And we have the computing power to kind of work with it. So in some ways, I do a lot of econometrics and I run a lot of regressions, and there's not really a way to do that by hand anymore. I guess like if this was back in like the 20s or the 30s and people like inverted matrices by hand, that sounds, maybe if you have a 10 observation data set, you can do that. But even so, like I don't know, like a 10 by 10 matrix isn't trivial to invert. So I don't know what you're going to do. Like last project I worked on, I think I had 10 million lone year observations, something like that, right? So we need to tell computers to do, just to estimate the models we have to do. And so there's really no way to get away from it, I guess. You just can't really do that work by hand, I guess. So in general, I think there's really, in economics research, there's very few fields that you could get away from telling a computer to do something for you. I mean, I guess if you're doing like history of thought, maybe you could just like do the old school reading and writing. Even then, there's like text analysis now. So hard to say. In general, I do think it's pretty essential. At least I realized I had to learn how to code in order to do all my research. I started in grad school. I mean, I guess backing up, when I was younger, I had some background in web design, and that definitely helped me kind of get used to telling computers how to do stuff, and certainly how to stay organized with my own file structure. I find that's like, before you even get to coding, like, are your files organized? That's half the battle right there, for sure. And certainly that might be even beyond learning the syntax of whatever language you're learning. I think for students, when I'm first teaching them, that's what having some type of computer background is definitely, that's kind of the biggest challenge for some of them. Like some are like running their projects out of their downloads folder or something like that. And believe it or not, like staying organized and having a solid file structure, that's, even before you write a line of code, that's like incredibly important to be able to just reproduce your research. And of course, reproducing your research is important, like scientifically in general. It's like the principles of science, but it's most important for yourself too, so that your future self can know what you did. But in any case, I learned coding basically like the way most grad students do. Like we teach ourselves. And maybe I had a couple demos in the econometrics courses I was in, but mainly it was just with Google and sitting down. How do I do this in whatever language I'm working with? It never works the first time. And so I'm Googling every line of code to first teach myself. I read a few books. There's a lot of books out there, and those all helped. When I first started with R. This was back probably 2010, 2012. And I really appreciated its open source nature. Free was definitely the right price when I was a grad student. But at the same time, back then, I didn't find R was overly well integrated together. And all the help documentation for R at that time, if you could read it, you probably didn't need it. That was basically the deal. It was written at a very high level of sophistication. And so very quickly, when I actually had to do actual analysis, I hopped over to Stata. And there's a lot of advantages to Stata as a first language. The syntax is a little bit easier. It takes fewer words to tell the computer to do something, though you do start bumping into some limits as you become a more advanced user. That being said, in general, you could probably get away with Stata and Latex if that was like I did for years. Honestly, like Latex to type all your stuff up and make beautiful tables, Stata to estimate all your models, etc. Now I've kind of switched back a little bit to R. Part of that is the institution on that. Stata is expensive, right? And CUNY doesn't always have the support for Stata licenses for everyone in the department. And so coming back to R is really interesting though, because over the last decade, it's become much more well integrated. All the packages kind of work together a lot better. The help manuals have become immensely better, and there's so many different tools for R. So R is a really good option for a lot of folks now. Pretty easy. In general, I still think estimating models in Stata is slightly easier, except for maybe really high dimensional panel models. It's faster in R now. FixEst is faster in Reg HDFE, which is what's used in Stata. But in general, yeah, estimating the models we do in economics is a little bit easier in Stata because Stata is made by economists for economists, essentially. That being said, any type of graphics are more beautiful in R. ggplot2 is just the coolest function or package there's ever been, and it makes the most beautiful figures. So that also, R can handle more diverse types of data, especially text analysis, a lot better than Stata can. So that's something to consider too. In general, the object-oriented language is more flexible than Stata with its macros, and it's a better bridge to other things like Python if you're going to go there. I personally haven't needed Python yet, so I haven't jumped that bridge yet, but in general, I guess a lot of my coding experience just it reflects the things I needed to do for projects. I mean, I think learning to code is great, and you should have a lot of basics like being able to track your inputs and outputs across different steps and break down a master task into different steps defined by the inputs and outputs you need to get across those steps. But apart from those basics, I just try to use what I need for my own projects, and that's basically how I've learned a lot of things kind of on the fly. I guess that's kind of the long and short of it. I don't want to take too much time. I'm sure we can circle back on any particular area or anything like that.
Thank you so much, Thomas. Tim, what are your thoughts? Or sorry, explain how is your coding journey?
Sure. Hi, everyone. I'm Tim Fong. Great to be here. It's nice to see some faces I haven't seen in some time, and I see Gonzalo is also on the call, and says, Gonzalo, hope you're well wherever you are. So my coding journey, I learned to code when I was in law school. I worked on a project where a lot of primary documents were not available in text format, well, in written format easily in a book, but they were available on a website. So what everyone else was doing was clicking through this very unpleasant sort of vintage 90s HTML, very disorganized, chaotic website to get the text that we needed, some legal documents. And I essentially sat down and said, well, this doesn't make any sense, and I'm not going to sit through here clicking through this nonsense when I want to search for phrases. So how can I get all the text? So that's what kind of led me to doing a lot of sort of shell scripting. Very, very low level. This is essentially, if you have a Mac, and I know Mac is very popular with a lot of grad students, with a lot of people generally. If you have a Mac, underneath the Mac is a Unix-like system, which is to say there's a tool that's called terminal, and it gives you very basic access to the file system and the guts of your computer. And there are a lot of applications that run in there that allow me to scrape the web, essentially to pull down these legal documents in bulk and then scan them on my machine at my leisure. That sort of one thing led to another, and sort of a longer journey into data science. But that's when I decided to go to grad school for statistics. And I knew that I was going to go probably into industry. Then Python, taking a survey of, I grew up in Silicon Valley. A lot of people in my friend group and my family work in tech. So it was sort of like, okay, well, given my interest, where should I put my focus, right? And so that ended up becoming Python. So as a data scientist, I've done some text analysis, did a little bit of a pilot program for Gonzalo at one point. I've also done things that are pretty strictly numeric, like human biometric data at a position I was at Magic Leap, where we built augmented reality goggles. So we had a lot of when you build a physical product that attaches to a human being, you take a lot of measurements. So done a lot of that kind of work. What I would really say is Python gives you flexibility when you're dealing with a lot of data and when you want to talk to the web. So I've had friends and colleagues who were in grad school and said something like, hey, I want to download a bunch of tweets and analyze them to do some sentiment analysis. What do I need to do? I know R really well, but this seems clumsy. And the answer is, well, you're probably going to have to use Python if you want to ingest large amounts of data and organize it. So if you want to do something like something I worked on my most previous role, where we had, 50,000 or more CSV files in a file system, and we needed to search all those CSV files for a particular set of phrases, so we could tell a client whether we had this data on our own in our own database. Essentially, well, CSVs are not a very good database, but that's how we had all the data. So that is a Python task. I would say, as far as modeling goes, I know modeling is a strong interest for people. Scikit-learn is a really great Python library. It is developed, when I first started using it a few years ago, like experimentally, it was pretty trash and poorly documented. Now there are essentially examples, fully worked out examples of, say you want to build random forest, which is a very popular model that people use, very interpretable model. I have random forest. I want to know more about not only the model itself, but how can I do feature selection? How can I display my model results? How can I display my feature selection results? What does my sort of workflow look like? Scikit-learn actually had, the last time I looked at it, which was probably a couple months ago, this incredible step-by-step what to do at each step. Now, as soon as you already know the underlying statistics and you know the underlying algorithm, which you can learn by reading, in this case, the Leo Breiman classic random forest paper. If you know that, you can just read through like how to do random forest and just copy the code and modify it for your purposes. That will require you to be pretty familiar with the code and how to be fast. So I'll just talk a little bit about that, how to get faster. The classic, and Pierre, you may remember this because a lot of people do this, and Thomas, you might as well. But what I found to be super helpful is actually learning the Unix command line. If you are going to do this and you come from a humanities background like I did, the most important thing you can do is to open up your Mac. Since if you're a humanities person, you probably coming from humanities, you probably have a Mac, is learn to use the terminal. You can buy books. There's tutorials, free tutorials online. And then here's a huge thing. If you think you might end up wanting to go to industry, I know some people who are like, I'm getting a master's, I might get a PhD, I might go to industry. There's a credibility gap that happens. If you don't, there are a lot of data science programs now, or there are a lot of programs now to teach people these quantitative methods, and you'll be competing with those people. Learn to use an editor. The classic thing is pick one, Vim or Emacs. You can just write that down, Vim or Emacs. Pick one and learn how to use it. They are completely free. And they are totally configurable. You can configure them badly enough that it will break and it won't work, and that's great. That's how you learn how it works. Once you've picked an editor and learned how to configure it really well, it's free, and you can learn to move very fast with the keyboard commands. And the other thing I would say that sort of helped me level up so that I could be in Silicon Valley around people who are either like, hey, I've been coding since I was 9, so I never went to college, and I've worked with guys like that. Or, hey, I'm a genius and I went to Stanford, and then I became this, I was good at math and I picked up coding in like 6 months at Stanford at the end of my education, worked with guys like that too. What you're really gonna wanna do is set up your Unix command line to use the hotkeys for either Emacs or Vim. And if you do that and you commit to using the editor, I take notes when I go to meetings or when I do anything at work and I write in my own personal journal, work journal, I use my editor, my command line editor to take notes, and I have it set up as a word processor. If you do that, you will get really, really fast. And there is nothing stronger when you have to go to a meeting with people who are professional computer scientists and you're coming out of academia or you're coming from like a non-traditional background than to sit down and be like, have them watch you use your own custom Vim setup with your own custom highlighting to take notes and then to write your code in the editor. That buys you huge credibility. And I cannot emphasize strongly enough that you actually will learn how computing works from scratch if you do that. So that's my pitch.
Did Kurt jump off?
Yeah, I think it's Kurt.
Okay, I trust that he will be back soon, but let me just jump in then with a short follow-up to Tim, because I think you've taken us pretty deep down already, at least from my level of understanding, into the nuts and bolts. So maybe just to back up slightly, could you clarify what exactly an editor does in this context?
Sure.
I almost understood it as like a way to code in shortcuts so that you don't have to
yeah.
go into the minutia as much. Is that correct?
Right. So when you write, let's just say you write something really simple. There's a website out there and you want to download a bunch of text because you have some analysis you want to do, sentiment analysis or something like that, which I know is very popular now. So you have to write, in my case, you will write a simple program to go out to the web, hit a web page, download all the information. In order to write the program, you have to write it somewhere. So if you were going to do, you're going to write your thesis, you would write it in Word or in LaTeX perhaps. So if you've used LaTeX before, and I know a lot of academics do, you've used an editor. There's usually some LaTeX package that you get and you write, and then you add little tags in, right, to make it formatted the way you want. So any kind of code you write, if you write, say, a Python program to hit a website and download everything, that needs to be done in an editor. Now, you could technically use Notepad on your computer to do that. That would be a very bad idea, but I think I did that very early and had a miserable time. So editors are specifically editors for coding, and Vim and Emacs are very old, very popular, and very free, highly configurable editors for coding. Now, there are also things you can buy if you have, or you can download that will be not command line oriented, so that don't require you to go into the terminal. You can get something called PyCharm. It's super popular now. They have a community edition that's free, but PyCharm is really complicated, and I'm not sure it's that helpful. I watched my coworkers who came from like mechanical engineering backgrounds really struggle to get PyCharm running on their machine and figure out all the options. So, you know, you can do it that way. There's also another one called, there's Anaconda, which is a package manager. If you're going to do a lot of scientific computing, Anaconda gives you all the libraries and modules you need for R or Python, and an editor that comes packaged with it. That's also free and super popular. So that's another way to edit your code. And the other one, if I should also mention, probably the easiest, let's get started, but like most disorganized, would probably be what they call Jupyter Notebook, which again, you can get inside of Anaconda as a free thing packaged together. That can be a really good quick jump start into Python, Anaconda, because it's a one-click install, and you can probably get support at your university for using it. And it's a lot of grad programs, I think, are starting to push kids to use that, push people to use that now. Does that answer your question, Heska?
Yeah, that's helpful. Thanks so much, Tim.
Sure.
I think Kurt is still on the way, so I
Quick
will.
little two-finger. I was going to say really quick, and for PC, like Notepad Double Plus or Sublime work pretty good if folks are on PCs, and they're free too.
Thank you. Yeah, I think chances are there are a bunch of people on the call who are more from the PC world than from the Mac world. So if we can cover both bases, that's super. I want to bring Pierre back into the conversation too. I think Kurt meant to ask a follow-up on maybe the different languages and how they relate to specific types of research within economics. So comparing Stata, R, and Python depending on the research project. Is that something you can comment on?
Yes, yeah, of course, very good. Nowadays, I use mostly one of those three languages. It's either Stata, Python, or MATLAB, depending on a variety of factors. And if you are starting as a young economist, I would argue, I would think you would have to think about the following factors in choosing a language. First is, I would say, speed of execution versus speed of prototyping. If you are thinking about using a program only once, say for a research article or for something very specific, so to speak, as opposed to something that will be used repeatedly and so on and so forth later on, it's probably best to go for a language that allows you to really fast develop a program and helps you get the answer you need. Rather than to get the right structure where the computer will actually execute it very fast or faster, more efficiently. So Python, for instance, is very good at that. Like, it's very good at allowing you to develop new ideas quickly. It's a very forgiving language. It's also a very general language, and it allows you to go in a lot of directions very fast. If you're looking for efficiency, like speed of execution, for instance, if you're about to churn like massive loads of data and you're going to do this often, then it's perhaps a good idea to invest some time in a programming language where the speed of execution will be faster, although you will have perhaps a little bit more difficulties to write the program because the language is less forgiving. So C is a good example, perhaps the least appealing because it's a very hard to type language, but Julia, which is a more modern language, could be a good example of fast but still kind of easy to develop for that purpose. And then perhaps the two other factors would be, with whom are you working? If you're working alone, it doesn't make any difference, right? But if you're working with the public sector, for instance, or if you're working with a team in academia and so on, there might be a dominant approach that is being used by the team you're working with. And so if you're trying to leave a legacy, so to speak, like leave a program that will be used later on for some purpose, it might be a good idea to actually have some knowledge of how they work. And so the industry standard for sure in economics is Stata, right? So learning and getting a sense of how Stata works is a very good idea, even though if you're not an econometrics buff or whatnot, you might encounter some people that will use it later on, and being able to interact with those people will be helpful as well. At least being able to read the code and the output, I would say, is something that might be interesting. And then the last factor I'd say is, do you need something that is highly specialized, or do you need something, or will you be on a project that is more general? And to take the example from Tim, for instance, who said, I'm going to, just take a raw input of data, do some calculations on it, and then put it on a website or something like that, requires some sort of general language that needs to be efficient at doing all those tasks, as opposed, for instance, as just doing statistics, right? Like a very specialized task, that is computationally demanding, but also very specialized, right? So if you're into a general purpose plan or program, so to speak, a general language will be much more helpful than a specialized one. So Python, for instance, again, would be a good example, as opposed to R or Stata or eViews or whatever statistical language specialized to the economic model you're working on. And if you're into really advanced research, it is most often the case that the research you will do will not have any pre-programmed package available in the software that you're using. So I find Stata like tremendously helpful for repetitive, I would say, common statistical tools like, regressions, nonlinear regressions, VARs, and so on and so forth, which are kind of like workhorses of econometrics. Like they're well-known, they're well built in the software, and so on and so forth. But as soon as you start thinking about something very specialized, like very dedicated, so for instance, to a public policy or a given program where you need specific equations and so on and so forth, very fast, a general purpose language, or at least a broader language which is easier to program, will come in more handy. So MATLAB, for instance, would be one possible choice, or Python again will be helpful as well. I'm not commenting much on R because I don't know the language. I can see the very nice graphics, and I completely agree that it generates a very nice output. But this is not a language I know very much. So there might be some, some things that can be done with R as well, in the things I'm talking about. But yeah, generality versus specialized things, working in teams versus working alone, or speed of prototyping versus speed of execution, I think would be the main factors in deciding what type of language you should use.
Thanks so much, Pierre. I think Kurt has successfully returned, so I will turn things back over to him.
Yes, thank you so much, Heska, for stepping in. Sorry about that inconvenience, everyone. But I think what I want to ask next, so I find one of the benefits of knowing multiple languages is that it kind of makes you more able to work with different teams, right? For example, like I know R the best, but then if I have a professor who wants to work in Stata, I have to know Stata. So I was just wondering if and let's start with Thomas, have you ever had a moment when you were like, oh, I want to do this thing in R or Stata or one of the two languages, and then someone else was like, I have no idea how to do that. Can we use Stata? And just kind of dealing with those types of issues when you're working in larger teams or groups.
I mean, so I was probably the one who was like, hey, why don't we just do it in Stata? But no, I mean, in some ways, right? Like if you're going to do empirical research in economics, you have to know Stata. There's just no way around it. 90% of econometricians write in Stata. And even if you prefer R, you need to be able to look at the replication kits, which are in Stata. And then you need to know how to use the right, like, for example, robust standard errors that Stata uses, just so you can replicate the existing research. And yeah, you can do that in R, but you gotta use the programs that mimic Stata, basically, in some ways, on some level. So yeah, I find for at least econometrics, if you have R and Stata, that handles most of what you need. If you start getting into the more burly text analysis type stuff, then yeah, Python is probably going to make some sense, though R can do quite a bit of text analysis too. Yeah, in some ways too, like I think in some ways I'm a little agnostic on the specific language too. And it's something I tell my students too. In some ways, if you have a limited amount of time to invest, like we all do in learning skills, it's almost better to just get better at econometrics than focus on like, I want to be a coding wizard. Because at least what I find is once you know what you want to do at a pretty detailed level, like what, all the different pieces you're working with, getting a computer to do it isn't terribly difficult. And if you need to Google some new syntax or some new programs or write your own program, you can do it as long as you have a really good idea of what you want to do. But what I find for a lot of students who are first learning it or people coming into new projects, it's like they don't exactly know what they want to do, and that messes up their ability to code what they do, right? Like, so getting very clear just on the things you need to do, the tasks that you actually have to accomplish. I think that helps a lot. But for working with others, at least in Econ, R and Stata and econometrics, definitely, that gives you a wide ability to do the things you really want to do. But I don't know, I'm not like a coding wizard either. I can do whatever econometrics I need to, but I'm sure once you start going out into the other frontiers of analysis, it becomes a lot tougher. Yeah.
Pier-André or Tim, do you have any follow-ups on that?
Pierre, please.
Well, Tim, you haven't talked yet, so I'll leave you.
Oh,
first.
okay.
The first.
Sure. So when I've been in roles where people pretty much wanted to use Excel for everything, and so I had to use Excel, even though that's not my preference. Although what I would say is sometimes it's good to learn how to sell your projects. I mean, in whether private sector, public sector, you need to convince your colleagues. And so I often would just say, well, I think R would be faster. And because R has all these, we were just running regressions on, I don't know, 20 or 30,000 row Excel tables. That's not a big deal to get people to use R, and just to say, look, this is actually faster and you can do this. And there's these statistical packages and you can do that. So to echo what Pierre said, having something that's pre-built is really helpful. I mean, we weren't going to use Stata at a private company, but I would say the other thing to think about too is if you find yourself in a situation where like you only know one language and you're asked to do something. This happened to me in graduate school. I knew Python. We wanted to do some computer vision stuff. Python is slow. As Pierre put it, Python's pretty slow and was not the ideal language, but the person I was working with wanted to use Python. He was a professor, I wasn't, so I kind of had to do that. You can also, and I really want to pitch for this, there is a lot of hosted services available. So there's Google Cloud Platform and there's AWS. So what I ended up doing is just saying, well, Python's really slow, but I can essentially rent time on a really fast computer through Amazon rather than even building my own Linux system to sit on my desktop to replace my, Mac, which is not really ideal to do computer vision research on, my Mac laptop that would melt. And the answer was, I can rent time on AWS for, less than $50 if I'm really parsimonious with my code. And I really, as Thomas was talking about, planning it out, like I would actually sit down, either whiteboard with the person I worked with my colleague, or with a pencil and paper, figure out exactly what I want my code to do, run a prototype on my local machine, and then log into a Linux, essentially a time sharing system. Well, no, log into a Linux virtual machine on a server, basically another computer where you rent time and space, and only run the stuff I need to run. And so even though Python is super slow and C would be ideal for what we wanted to do, if you get enough computing horsepower and throw it at it, then you can solve your problems really quickly. This is not ideal, but if you have to and you're stuck with something like that, that would be my push to just rent space and time.
if you have a powerhouse at your disposal, then the efficiency problem is much less important. I agree. I want to underline the importance of what Thomas mentioned earlier on in specializing in one language, learning in a deeper way one language first, and then perhaps learn other languages as well. Because I think is right. First of all, it can be a daunting task, right? Like if you start, you don't have much knowledge about computers and so on and so forth. Like focusing on one will ease the task in learning by several folds, 10 folds, 100 folds, whatever. And most tasks are mostly the same from one language to another. Like basically a computing language is something that tells the computer to do loops, to open or close files, or to do calculations. Like that's the basic of it. And once you learn those, those simple tasks in one language, the structure of those tasks permeates somehow from one language to another. There's some little exceptions. I would argue that R and Stata are pretty unique in their syntax. Like if you learn Stata syntax, it's not going to port well to Python, for instance. It's not going to port well to R as well, because they have a kind of a closed view of how they structure their language. But with general programming languages such as Python, C, or what's Julia, for instance, the structure is pretty much the same from one language to another. But learning one, despite that caveat, learning one language first and learning it well is probably the best way to start if you're trying to figure out where you should go.
Well, thank you so much. And I just want to pinpoint one really unique point that I think came out through that discussion is that Tim said that you don't need, you wouldn't really use Stata in the private sector, where Thomas was pointing out that if you want to do economics, you have to learn Stata. And I think it's not only from a networking perspective, but also it's just what most regressions are being done in. And now I think another kind of famous, I think we can call it a debate, is the latex versus word concept, right? Yeah, I see Pier-André, I'd like to respond. So here, let's go back around the circle. So Thomas, latex or word or both, or how do you manage that?
I mean, obviously LaTeX just looks way more beautiful. And like, I mean, how are you going to make your regression tables if like I get R Stata just to write my LaTeX table for me, and like automating all of that is so important, because if you change one specification, right? Right? Say you have a regression table and you estimated like 10 different models in it or something like that, right? And you change one of them. Like in Word, you'd have to like go back by hand or something. I don't even know how you would do it. Like I know I could get, I can output my tables in Excel and then maybe cut and paste them. It sounds like a pain in the ass, basically. But if I get the program to write my LaTeX for me, it automatically updates in all my papers. So it's a lot. I mean, yeah, I'd say just learn LaTeX. It's a lot easier. I don't actually code that much in LaTeX outside of like my tables. Usually I use licks. That it gives me a little what you see is what you mean interface, but whatever is good for you, use it. But yeah, I don't know. I mean, Word, if it's just a pure text document, maybe I'll use that, but I haven't even set up my Word to have like a reference, a citation manager yet, because I use BibTeX. So I don't even know really how I would write a paper in Word. Like the idea that if I wanted to change my style, like for like my section headings, I'd have to individually change each heading. It just sounds like a great way to make a mistake. And so whatever your workflow is, try to automate things and try to have all your instructions in one place, because if you make a mistake, that's the one place you can make it. That's one thing I would say. Like I would almost refuse to use Excel, because you're going to make it's also me. So like I'm scared of Excel errors, right? Like my greatest fear is that someone's going to find an Excel error in what I do and put me on the internet, right? Like, so I just refuse. I'd be like, unless we want to destroy this project, or like, because another thing is like, when you're doing this coding, a lot of the times you're doing it when you're tired, right? Like we're all like, every academic I know is tired on some level, and grad students are the most tired, right? And a lot of times you're doing coding work, it's not when you're most fresh, because like when I'm most fresh, I'll be doing like idea generation work. And then more of like that, the coding, housekeeping, implementation stuff, I'll do when I'm a little tired. And like, you're going to make mistakes. So you got to have a little workflow thing. But between, yeah, LaTeX or Word, I couldn't imagine using Word for most professional documents. It just seems like a great way to make mistakes or waste time or anything like that. So yeah, LaTeX, just it's worth learning some bit of that for sure.
Tim?
Yes, so just trying to read Pierre's. Pierre has a great message here to about certificates. So I will say versus LaTeX versus Word. When I did have to write something for academia, which was in law school, I used LaTeX and not Word because lawyers like to really grill you on the format. And where in my program, a lot of people had to redo their final requirement. Was required to graduate to write something that was around 50 to 100 pages. And if you didn't have the correct margins and headings, they would refuse it. And then you had to do it again until it was done, which is not something you really want to do right during finals or graduation. So LaTeX, I took one look at that and I said, well, I can write a LaTeX style sheet and then everything will be correct and I'll never have to think about it again. And then I'll just focus on my text. And if I could use LaTeX in my professional job when I had to generate, briefing documents as a data scientist, I would, but other people don't want to do that typically. So, I'm in a Google Doc because that's what my colleagues want. And they want to be able to work on it collaboratively. But LaTeX versus Word, definitely LaTeX. As far as programming and certificates, yeah, I mean, in industry, no one cares. If they care enough that they want to really care about your coding skills, they will force you to take a programming interview, which is very unpleasant. Nobody likes that. Well, I mean, maybe there's somebody who does, but most people don't like it. And so what I did is I took a boot camp for programming interviews where it was just every day doing lots of problems with people yelling at you about how simulating an actual interview. Not fun times. You can also read this book, Elements of Programming Interviews. Oh, it's blurring it out. Anyway, Elements of Programming Interviews, which a lot of people use, but that's a really specialized topic that you only care about if you want to get a job in tech. So yeah, I would say don't worry about taking any kind of certificate. If you need skills to program to pass interviews, take a programming boot camp specifically for that.
I'm a hardcore fan of LaTeX. I try to use it every time I can. I exactly like Thomas, most of my writing workflow and revolves first around some heavy statistics or heavy programming and simulations, and it's so easier to integrate the results in the final paper with LaTeX than results figures and tables with LaTeX than with Microsoft Word. And then I have to work with the government, and working with the government, no one knows LaTeX. No one even knows what it is. And if you're, Excel is some advanced software and whatnot, then it's a very different paradigm of writing and executing tasks. And so I need to adapt. I need to, frustratingly write in Word and try to write more than 5 or 6 equations with Microsoft Word, and you'll soon learn the benefits of LaTeX. That I can promise you. But it's a given that in the public sector you need to work with what they work, and they use Microsoft. So that's the way it is. I would say you need to understand Word. I mean, to some extent, in the sense being able to write a paper, for instance, with it. Fortunately, it's not very hard. I mean, it's designed to be easy to use, right? Except for very, quantitative research, I would say producing matters, then it's a little bit harder. But I think you need to know Word as well.
I have had to convert LaTeX PDFs to Word for a journal before when I was submitting to it. And that's definitely the least fun task I found. I think it made me very sad for a couple afternoons.
There's a very good package for that. I mean, there's a Python package for that. I remember, I forgot the name of that package. Let me Google it and just paste it in the comments, because it eases the tasks a lot. It doesn't number equations, but at least it's able to somewhat write them in an understandable way. So it saves some time, basically. So I'll just find it out.
I'll check that out. I looked at a couple of them and I played around with them, but none of them I found, at least I didn't find anything in Python, but nothing did it better than like Word's own like PDF converter thing, and even that was jammed up and like it. Anyways.
I agree with you. It's a daunting task, and you have to spend some time on it. Like there's no magic easy to push button thing. Like you need to edit it at some point.
So on this note, I just want to, and maybe we'll start with Tim. Are economists just glorified computer programmers now, or what would you say is the difference between like a data scientist or statistical programmer and an economist, in your opinion?
I would say that it would be easier for most economists to, I mean, I guess I'm stuck in this like Silicon Valley tech mode. It would be easier for economists to do what I do than it would be for somebody who was only trained to, say, coming out of a data science college program, because there are undergrad data science programs now, to do economics. And the reason is because, econ, in my experience, is about this idea generation that Thomas was discussing. And often, my day is, even when I have to work on something that is, say, statistical inference, a lot of it is sort of managing the data fire hose from somebody else, or talking to an engineer about, when I worked at Magically, about some mechanical engineering problem that I'm going to attempt to solve with a statistics approach. So that is, I think economics is still its own discipline. I think, the computer science tools are really powerful. I think somebody in the chat said, talking about taking computer science classes, I think they're really powerful computer science tools, but economics, how do I say this? I think the history of thought, since Gonzalo was here, and we used to talk about this at the office sometimes, computer science has its own assumptions. It has its own ontological assumptions, and computer science people can get in a lot of trouble because they don't think that they have assumptions. They think that life, and you see, if you work in tech, you'll hear this all the time, that everything is an algorithm and everything is computable, and I am beyond ideology. I am beyond, I only deal with reality because I do algorithms. And this is something you will hear people say at lunch. It's like a common thing. It's completely and wholly delusional. And I think everybody here, this is an INET YSI panel. I think everybody here is too smart or too educated to fall for that nonsense. So I would say that economics is separate. Computer science has its own sort of underlying ideology, which is generally unexamined, and that makes it not the same as econ, at least the sort of pluralist econ that I think most people here aspire.
Yeah, I kind of think that, like, for me, coding is wholly functional. It's like, how do I want to execute the ideas I have in my head? But it's the ideas that I have in my head that makes me an economist. And what that means is different to different people, right? Like, some people really think economics is about studying individual behavior. For me, I really don't care too much about what drives an individual to, take a left turn or eat a piece of toast. I study economic institutions, and very powerful ones, and that's what makes me an economist. But that's because I like political economy, kind of macro-y type stuff. So it just depends what you're into. But for me, coding is just functional. It's like, how do I implement my idea? And that's why I kind of focus on figure your ideas out. And once you really know at a fine-grained level what you want to do and all the different component pieces of what you want to do, how to actually execute that isn't all that usually complicated. I mean, it is, and you have to spend a couple afternoons with Google and looking at all this other stuff, cobble together code fragments and modify them, etc. But it all comes from like a deep understanding of what you want to do. And so and having like some reasonable fundamentals about how to translate your ideas to a computer. And then what language you use, I'm a little agnostic about that. R and State have been good enough for me, but if I needed Python, I'd pick it up. And I'm sure some things in the future I'll get into. But yeah, stay organized, have a good workflow to minimize your errors, and then just divide your tasks into subtasks by tracking like the things you put into it, each task, and the things that come out to it, and how each language accesses those. And then you're pretty good.
Let me say that if economists are glorified data scientists, or the other way around, I don't remember, but I would say that then it's a sad state of affairs. I hope it's not the case. I think, Tim and Thomas made some very good point about, thinking about social ideas and the way the world works, so to speak, and then coding being an extension of this in the numerical word. Like, it's just a tool to achieve the demonstration of some ideas. I think there's a very wide difference, conceptual difference as well, between computer science and econometrics in the way we conceive causal relationships as well, or transmission mechanisms as well. We are much more in economics, I think, much more interested into why some result is, rather than trying to reproduce it or find a model that explain it in a kind of a black box way, right? We're trying to figure out why things are the way they are. So it's kind of a more of a science approach than engineering, so to speak. And I think programming does not solve a lot of the inherent questions that we think about in economics. I mean, to be able to program a model, whatever economic model that is, you need to think very carefully about the assumptions that are embedded in that model. If you're thinking, you need to instruct a computer that you're, for instance, thinking that agents are maximizing the utility, if that's what you're into, right? And so the computer will just do that. It will not, tell you, oh, maybe that works in that situation and that doesn't in other situations and whatnot and so on. So you need to be thinking critically about those behaviors, and if they do actually work in the context of the problem that you're trying to tackle, so to speak. And, even simple ideas like whatever predictive model that you're building is dependent on data that has already happened, right? So whatever the model you're thinking about, it's always based on past observations. And so you need to think about ergodicity, so to speak, right? Is the past good at predicting the future, or is it not applicable in the context of what you're trying to do? No programming language will tell you what's the appropriate answer for that. And if you want to have some meaningful conclusions about what you're trying to study, you need to think very carefully about those things before going to a computer program.
Well, I think we've hit a natural time to open up for the questions from the audience. So I would invite any of you, whether you want them to put them in the chat and I can read them out to the panelists, or if you just want to directly ask them yourselves, please feel free to do so. And I'll give everyone a few seconds to get their questions ready and contribute.
While folks are writing that down, one resource I'd recommend, like I know I mentioned, staying organized, reproducible research, and just having a good file structure. The best single one-stop shop resource I ever found for that was called Code and Data, and it's by Gentzkow and Shapiro. And most economists, we're not computer scientists, so we learn all this stuff by making mistakes, right? By being disorganized, and then like having, someone on the team being like, what did we do 6 months ago, right? And then we'd spend 2 afternoons figuring that out or something. So that's a really useful thing. Another thing I'd recommend is, I'm not sure, like a lot of my own coding, I had to teach myself, and it was all kind of a part of the econometrics courses I took. But something else that was really helpful when I was a grad student, there was the Institute for Social Science Research, ISSR, over at UMass. I know at Michigan, there's the ISR, Institute for Social Research, but they put on a lot of really good seminars about how to, like, I don't know, I took a scraping one in R, or a lot of really good basic or advanced data type things. And those are really useful. Even if you don't get, like, I don't think, at least for anything I do, like having a formal certification didn't help. That wasn't better than just like putting on your CV, I know Stata, R, and Latex, right? Because if they're ever going to test you on like, can you do this? Then you have a little coding task in your interview, whatever. But all those classes, if you can take them, they're usually pretty useful. And it can be a good way to spend like a weekend or a couple afternoons or something like that.
Thank you so much for that, Thomas. And I just want to let the audience know, and I will be kind of compiling all the notes and then all the resources we've been discussing. So you'll just have a one-stop shop or a one-pager just for all those good little insights. But I also want to ask one of the more like human, because I think when we talk about technical things in computer programming and things like Stata and R, is you kind of lose the human aspect of it. And what I mean by that is, I know over the summer I had about a 3-day freak out, and then I found out that I just put a period in the wrong space in one of my 240 lines of code. And you get very negative and down on yourself and stuff like that. But I think it's important, and please, panelists, feel free to disagree, but that's how you learn how to code. And you can't avoid that, and it's gonna suck. And I just want to kind of just maybe if the panelists could share any of their personal experiences with that, I'd really appreciate it.
Yeah, I want to really emphasize for new students that the first time you write a code, it never works. I mean, maybe the other panelists are better than I am, but there's any chunk of code that's over like 10 lines is going to have a typo in it, and that's how you learn. You got debugging your code and learning to teach yourself what you know and why your stuff doesn't work. That is coding, right? That is the #1 skill. It's what always happens. And so many times when I see my students struggle, it's because they quit, right? Like they come to the first error, they don't know what's going on, they quit, and they come ask me. And like, yeah, don't quit. That's you not quitting and you Googling your problems and going through your code line by line. That's how you learn to code, because it takes you down all these different pathways to answer your question. And that's, rinse and repeat, do that for a couple of years, and that's how you learn the language. And so many students, I think, they think that they should already know how to do it and it should just work the first time. But it really doesn't work like that. You're going to make mistakes, and then you need to figure out what those mistakes are and how to fix them. And like, that's the process of learning to code. And that's the process of coding as well, not just learning, because you're always learning new stuff, right? So yeah, don't quit. Just keep on going, spend the afternoons, put that stuff into Google. You will have an emotional roller coaster. I've been very frustrated at my code. I have definitely cursed at my computer. I want to throw my laptop out the window. And then also at the same time, like when I got my code to work, or like I estimated a model for the first time and got like a result that wasn't bogus, like people have heard me cheering down the hall. I was even, when I was like a research assistant, a visiting scholar at the St. Louis Fed, it made me realize I never want to work in cubicles, because like I estimated a model and like I got my first initial result. I was like, fuck yeah. And then like the kind Midwesterner who was in the cubicle next to me was like, excuse me, can you please not curse at work? But I was like, geez, I need to go back to academia. This shit isn't gonna work. But anyways, yeah, you got to manage your own emotions. It'll be frustrating, but that's just the game, you know. Just don't quit. If you quit, you stop learning. And there you go.
I agree completely with Tom. Like, the entry cost is super high. The first program will take a lot of time. You will curse, you will swear, you will cry, you will do all those things. And then at some point you'll find that it works and you'll curse again and cheer. But the good thing is that the next program is going to be easier, the next one much easier, and so on and so forth. The only thing I would add is that, you know, there's one worse thing than spending hours on coding because of a programming error, and it's not coding at all. Because if you do your research paper, you know, just by entering comments, for instance, in Stata line by line, and say, oh, all my graphs are done, all my tables are ready, and so on. And then 1 month later, you realize you made a mistake and you have no script file to actually figure out where you did make your mistake. Then you need to start all over again. And you need to remember what you've did, which is not obvious if you haven't put some time on it in the meantime, and so on. And so learning to code, or putting your methodology in a script, so to speak, helps tremendously if there's some repetition down the line. If you're doing something more than once, especially, for instance, if you make a mistake, but if you're using the same program 2 years later, it's going to be a very good way to refresh your memory on how you actually did something the first time.
Yeah, tough act to follow here for Pierre and Thomas, who both said great stuff. The only thing I can add substantively is just break stuff as fast as you can. I spent a big chunk of I've spent some time in my life working with machine tools, growing up and as an adult. And when you break something that is like a machine tool part, you will be sad while you wait to go to the shop to get it fixed, or wait till you order some parts to arrive, or it was just really expensive and now you've broken it. And the good thing is, it is very difficult to actually break your computer. Like, you can, when I say break your computer, I mean like physically destroy your computer. That's actually pretty hard. You can do all kinds of stuff where, like, wow, it won't even start up again. And that's fine. Like, you can fix that unless you have done physical damage to the machine. If you screw it up so badly that your operating system crashes and you can't, as long as you that's what I'll say. Back up your data, have an automated, I just skimmed this Genskow and Shapiro table of contents as version control. So version control off your machine. There's something called GitHub. It's generally free. Please use that. And have a physical backup hard drive. Pay for the software, run a backup. Because, okay, and you will, if you get really into this, you will brick your machine, you will screw your machine up, you will crash the operating system. And that's okay. You just restore from backup, and who cares? And that's actually a learning process. If you get a Linux machine and you destroy the operating system, that's fine. You just reinstall the operating system and you have a backup of your data and you're fine. And that's a learning experience too. And it's the beauty of this and why you can learn really fast. The other thing I would say is debugging tools. If you're going to use Python, learn to use the debugger. I didn't for a long time until I worked with a dude who was a super pro phenom CS guy, and he showed everyone how to use the debugger one afternoon, and we were like, wow, we should have been doing this our whole lives. We're dumb. So learn how to use the Python debugging built-in tools if you decide to go that route.
This is great. I just wanted to, sorry, Kurt. I just wanted to jump in with a brief comment, because I think your stories of how to kind of go through this journey and deal with all the errors and the errors and the errors until it works, it just drives home the point that it's so important that what you're researching is actually interesting to you, and that you're asking a question that you actually want to know the answer to, which is something that we always stress and run into in YSI, right? Because many of us, sometimes we feel like we don't get to ask the questions that we really most deeply feel we have. And it's when we allow ourselves to work on those, and we make time in our schedule, maybe sometimes outside of the textbook or outside of our curriculum, to work on those, that we find the energy to deal with the errors and deal with the disappointment until it finally succeeds. So this is not really a question. It's just kind of like, you know, let's remember to do the work that's most gratifying so we can actually climb that mountain, which we often support each other in this community. So
No,
just
that's
a
an
little aside.
incredibly important comment too, because you got, especially for grad students who are selecting like dissertation topics, right? That's that you better you got to be interested in what you're doing. It's got to be something super important, or at least that you find important, because you're going to be writing that paper. Like the dissertation on average takes about 2 to 3 years, and then right, what's getting tenure is basically publishing your dissertation plus a couple other papers, right? Dissertation is 3 papers, you probably need 5 to 6 for tenure. So you're going to be like, you're gonna, so you write your papers for the dissertation, then it's another 3 years to get them published, right? So that's like, you're gonna be living with these things for like 6 years, and you're gonna be rewriting them because the referees are gonna beat you up, and like you'll have satisfied your intellectual curiosity and by roughly year 2 or 3 at most, and then you're still with it for 3 years, getting beat up by refs. So like, you really gotta have something that's interesting. My one rule of thumb for the projects I work on is, does the topic scare me? And if I'm a little bit scared, that means it's important. And all the things that terrified me were all meaningful, like the Reinhard Rogoff paper, that terrified me for sure. And it was even scarier once I published it. Then, working on mortgage fraud, right? Looking at trying to estimate, put a number on how Wall Street committed mortgage fraud and the losses due to that during the financial crisis. That was pretty scary too. Then the new project I'm working on, I'm really excited about, is this new project on the music industry. And that scares me for some other reasons, but it's also incredibly important. And so that's always been kind of my my barometer, my rule of thumb. Like, does my project scare me a little bit? If it doesn't, then I don't know. But hey, other people, have different rules of thumb.
No, that's a very good point. SK and Thomas made it home as well. Made a home run about talking about it as well. I would add, if you find an important difference between what people say about a topic and what the research or the literature says about it as well, there's probably a very big gap there for an applied research paper, so to speak, in trying to find out or reconcile why those differences are so important. Like maybe the theory is wrong, maybe applied policies are wrong, maybe it's a little bit of both, but there's something probably there that might help you drive an idea into either the public sector or into a published applied paper.
Tim, any thoughts on being terrified when coding and how it leads to good analysis?
Yeah, I mean, it's, in the private sector, you're on a time constraint and there are investors or a stock price that you're looking at. So pretty routine to think, wow, this might not work, but you are going to have to figure it out. And I found that at some point you're just like, okay, well, I'm gonna do the best job I can to do this. Maybe you're pushed to be, my experience, sometimes doing things that I've never done before or far outside my expertise, but like you are the only person, so you're going to do this. Just right. I think Pierre, well, it's tough to follow both Pier-André and Thomas. Just write your code, just write it. Yeah, that's even if you're scared, or especially if you're scared, just start making some outputs and test early. Again, back to breaking stuff. If you do end up having to work with production data, which may happen, you may end up having to do anything involving like a database that other people touch. Just make sure you take a lot of backups and test things in a non-production way if you can. Take small tests so that you don't break the production database, break the production code. So that goes back to version control and being organized. And again, take a lot of backups. When I had, especially, when I was in grad school and I was working with a professor on some computer vision stuff, I backed up my machine every day. And I did need it at one point because I broke it. So yeah, back up the code, back up all your stuff.
And just, I just want to make sure that Rock had a couple questions about some languages that I just want to make sure we cover. SPSS and Wolfram. What about any thoughts about the effectiveness? Because I think so far we've really talked about for computer languages about that. Or maybe the better question is, do any of the panelists feel comfortable in SPSS and or Wolfram or use that?
SPSS is horrible. That's all I can say. I don't like it. I mean, it's not a software designed for people with a good background in statistics or econometrics. It's designed to be a push and play type of software. And I think it's very dangerous because sometimes you don't even know what's being done in the background. And if you care about, identification, ergodicity, whatever the paradigm you're working in, that's not the type of software that will help you elicit if it's being applied or not. Wolfram and Maple, which are two kind of mathematics oriented, and I would say algebraic mathematics applied type of softwares, are useful maybe if you want to have some help in solving formal theoretical models. Wolfram is quite expensive, although there's a free version online. It's quite expensive if you buy the computer desktop software. And it doesn't, if you're into modeling, it's basically kind of training wheels, right? It doesn't help you being self-sufficient, so to speak, in mathematical modeling. So maybe to use with caution if you're using it. That would be my advice.
One thing I kind of want to add here too, it kind of goes back to like the themes of like reproducibility of your research, and then not using like a plug and play system or a point and click system. So one of the most important things about using a script is that there's only like writing your own script or program. It's just like there's only one place you can make a mistake. And that's on the script or the program that you wrote, right? Like all your work is there. It's a systematic set of instructions. And so you can catch your errors, right? And that's so important. And that's part of reproducibility, right? That you have one script in one place, it'll reproduce your entire project. It's for you, your colleagues and teammates and the broader community so that you can catch your errors. You will make errors. You're going to be doing this when you're tired, or even if you're sharp, your finger's going to slip. And if you're just doing, it's like why I won't use Excel, right? Because if your finger slips when you're cutting and pasting a column, you don't have a way to know that, right? So let me share my screen really quick. I'll show you like a really quick thing to share this, right? So here's the Reinhardt-Rogoff paper, right? And here's that famous error. You double click here. This average is supposed to be the average of this entire column here. And look, it wasn't, right? You can just see they only average these observations right here. And so that's why you don't use Excel, right? Like if you do that when you're tired at 11 or whatever, you can't actually catch that. Whereas if you wrote it in a script, there's a single place you can catch it. So that's why you put it in one spot. So anyways, that's definitely important.
And here, so I know we're getting to the end. And I just want to thank all the panelists for their wonderful insights for today and taking the time out. But I think I want to give each of them an opportunity for kind of a final word or a final piece of advice. And I think a good kind of starting point or a good question would just be, if you had to start this all over again, what's the one thing you would do differently when it comes to coding and research? Sorry, I know that's a big question, but I think it's a good final note. I'll give you all whenever you have the answer, just feel free to speak up.
So if I were to do this again, I had the opportunity to take C at community college when I was preparing for grad school. I did not because the instructor was notoriously bad. And now that I've been in industry, I've never had the time to sit down and properly learn C. And I wish I had taken the time to grind that out when I actually had a lot of free time. It's probably something that's going to happen in the next year or two, no matter what I do. And I would have liked to have gotten in on that early. And I probably would have taken more computer science classes versus just kind of winging it. Yeah. Oh, one last final word. Another pitch for editors. If you have the problem with like the periods or spacing and all these things, if you have a really good editor, whether that's PyCharm or you set up your own Vim or Emacs setup, a good editor will catch a lot of that. There are tools to do that, and that will again accelerate your speed of coding pretty dramatically.
I think if I were to, if I had to start all over again, I would, perhaps put more emphasis on the two following things. First of all, I would pay more attention into data cleaning routines. This is so boring to be done. And if you work with, government data sets, they're awful. They're like always, they're never intended to do statistics and whatnot. They're often designed for operational purposes. And so there's so much work that needs to be automated and done in order to make a clean, usable data set for, research purpose. So I would put more time into automatic detection of errors, so to speak, or, paying more attention to that. And the second thing I would do is I would comment my code more. Because the first time you write it, you're just into your flow and doing your stuff. And then, I'm now 10 years older. I look back at my original idea and I'm like, what the heck was I doing? I don't remember exactly what was written and so on. And commenting your code helps you, understand what you did back then and so on and so forth. It's also a good reflex because it helps you see the disconnect between what you think and what the computer actually does. So that might be helpful as well in detecting programming errors.
There's a lot of skills I would like to have now, but I'm not sure if I would do anything really differently, because basically my education in coding was like, how do I solve the problems that I'm confronted with in any given project? And I was able to solve them. There wasn't anything that I wasn't able to do. There's a lot of things I would like I'd love to be better at text analysis, but that just means I need to get into a project where I'm scraping a lot of stuff and then I'd get better at it. Yeah, I probably should have commented a few things a little bit better. That'll be past Thomas helping future Thomas a lot more, but I'm decent at it. And when I don't, you learn from it. I don't know, there are things I'd like to be better at. And scraping is probably the number one thing. But if I need to do that, I'll teach myself. So hey, maybe like I would like to have invested more, but I had a limited budget of things I could invest in the past, hours of the day and the like. So I'm not sure. But yeah, certainly like getting Python would be the next thing I'd probably add to my toolkit, and then scraping things if I needed to. And it would be fun to work on those projects.
Well, again, thank you so much to our panelists. Thank you so much for our audience. And like I said, I will be creating a little one-pager of all the great links and kind of little pieces of advice that we've gotten from this panel today. And I think I'm going to hand it back over to Heska for some final words from YSI. And again, thank you so much. And we will speak soon. And there will be other early career times coming soon.
Amazing. Thank you, Kurt. I think this was fantastic. Thomas, Tim, Pier-André, this was amazing. Really, really appreciate your detailed and personable and entertaining as well as insightful comments. I think we all walked away with a lot to have learned. So I'm personally grateful, and this video will go up on the YSI YouTube channel. So we'll put all the links that were shared in the chat and Kurt's PDF. We'll put all the resources with that. And yeah, let us know, if there's other topics like this that would be interesting to delve into. You can write YSI, you can email us, you can tweet at us, you can put a comment below the YouTube video, you can Facebook me, whatever. find a way to share those ideas, because we'll try to keep this going. It seems to be very helpful to many of us. So again, appreciate those who joined us live, and a big thank you to the panelists and Kurt for putting this together.
Thank you, everyone.
Have a nice rest of your day.
Bye, everyone.